Hello everyone. Welcome back to Dr. Liu's VCE Chemistry channel. Today, let's learn together about the 2024 VCE Chemistry examination. We will focus on questions related to fuel and heat of combustion. My explanations may need to be revised. If any teachers, parents, or students find errors, please feel free to provide your guidance. The oxidation of glucose in the body produces carbon dioxide and water, and this reaction is not reversible. Cellular respiration is the combustion of glucose, but not oxygen, although oxygen is involved in cellular respiration. Hydrogen is one of the fuels with the highest density of energy by mass, which is much higher than glucose by mass. You can calculate the energy density, however, this calculation wastes valuable time. Remembering some general knowledge will save much time. We calculate the moles of oxygen, and then the oxygen needed if all the ethane completely reacts. We find that the amount of oxygen provided is less than that needed. So, ethane is excess, and oxygen is limited. We use the amount of oxygen to calculate the amount of ethane reacted, and the amount of ethane left. Producing a product from the continual supply of raw materials such as iron, ore, and fossil fuels is a typical example of a linear economy. The two quoted Sustainable Development Goals are not directly linked to the process in question. If we subtract 1 CH3 from compound J and add 1 H, we should get fatty acid for this methyl ester. To form the triglyceride through condensation, 1 glycerol should be added, and 3 water molecules should be subtracted. It is an esterification reaction, in that a triglyceride reacted with methanol to produce glycerol, and compound J. Esterification reactions are equilibrium systems with water as a product. Therefore, in the presence of water, any ester formed is going to potentially undergo hydrolysis and form the fatty acid rather than the desired biodiesel. Since the data book gives the molar enthalpy of combustion, not mass enthalpy, we convert the mass of butane to the moles. Then, moles of butane are multiplied by the molar enthalpy of combustion of butane, which is energy released through combustion. Substituting the value of mass and temperature increase of water into the heat equation, we calculate the energy absorbed by 100 G. The heat capacity of water is in the data book. The percentage energy efficiency is the percentage energy of water in energy released by butane. The second mark was awarded for the value being quoted to 3 significant figures. Lead nitrate reacts with potassium iodide and releases heat energy. This heat energy is measured with a solution calorimeter. The calibration factor and initial temperature are known. A solution calorimeter needs to be calculated because energy is needed to heat the water, and the internal components of the calorimeter, that is, energy from the reaction, is not solely transferred to the water. Without this calibration factor, we cannot use the change in temperature of an unknown reaction to determine an accurate value for the enthalpy change. Without calibration, the enthalpy value obtained will always be less than the true value for a given calorimeter using a fixed quantity of solution. Since the delta H is for 2 moles of Ki, we should divide this delta by 2 to get the heat per mole Ki. Using the heat per mole Ki, we calculate the energy least. Then, we calculate the change in temperature by the calibration factor of this calorimeter and add the change of temperature to get the maximum temperature. Since this experiment is repeated 3 times and has a high degree of repeatability, errors do not come from random errors. The results always higher the expected value. These errors should be systematic. The reasons should be that the concentration of Ki in the stock solution was higher than 0.960 m, the amount of Ki added to the calorimeter was too high, the total volume of solution in the calorimeter was lower than that used to calibrate it, and the calorimeter's calibration factor was smaller than the true value. In fuels and heat of combustion, 5 multiple-choice questions are awarded 5 marks, and 1 short-answer question is worth 11 marks. The overall score for this section is 16 marks. With a total possible score of 120 points, the percentage for this section was 13.3% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.